Hello, this is Sir Romy again, uh, discussing to you the 8th lesson, or rather the 10th lesson of the course, which is integrating factors found by inspection. Okay, now we have defined integrating factors before. Okay, this is a factor or that will make a differential equation exact when once you multiply it to both sides. Now this time we will do it using integrator, using using by inspection only. We will determine integrating factors by inspection. Let me give a simple example like this one: x plus y dx plus x dy is 0. Now this differential equation is actually homogeneous, so you can do the transformation y is dx here. This differential equation, okay, is also exact. Okay, I want you to just discover it for yourself, because the partial derivative of m here with respect to y is 1, the partial derivative of n with respect to x is 1. So this is both homogeneous and at the same time exact. Now let's do another way to do this. Okay, first step is just to multiply. Okay, we have x dx plus y dx plus x dy is 0, and then group this x dy plus y dx there, and then x dx, and then here we can use this formula: derivative of xy is x dy plus y dx, and then this can be replaced now by integral of x, or rather x dx plus the derivative of xy is 0. And finally, you can integrate. The integral is 1 half x squared plus xy is c. Multiplying by 2, you have x squared plus 2xy is another constant. It's possibly 2c, which is just equated to another constant. Let's call that just c sub 1, where c sub 1 is equal to, where c sub 1 is just equal to 2c. Okay. Now, these are some of the special differentials, some exact differentials that we can take advantage. Now, the first one is the derivative of xy is x dy plus y dx. The second one is the derivative of y over x equals x dy minus y dx over x squared. The third one, derivative of x over y dx minus x dy over y squared. Look at how this is differing. One is starting with x, the other is starting with y, which is what? The denominator. And the denominator is also the denominator there. Okay, these formulas of course can be derived. Next is the derivative of the arctangent of y over x is x dy minus y dx, but this time the denominator is x squared plus y squared. The derivative of the arctangent of x over y is y dx minus x dy. Okay, the denominator is also x squared plus y squared. The difference is one starts with x, the other starts with y. The derivative of ln of y over x is x dy minus y dx over xy. The derivative of ln of x over y is y dx minus x dy over xy. Both denominators are xy, and one is starting with the denominator which is x, here starting with the denominator which is y. And then the last is the derivative of x to the p, y to the q. Notice that p and q are subtracted to 1 and then multiplied by py dx plus qx dy. So it will take you some time to memorize this, or just in order for you to recognize right away what particular formulas here will fit in to problems that you will encounter later. Let's have another example. Let's have x dy minus y dx is x to the fifth dy. Okay, notice that if I divide both sides by x squared, it will become x dy minus y dx over x squared equals x to the fifth over x squared dy. Notice that, notice that this is a common differential, which is the same as the derivative of what? The derivative of y over x equals x cubed dy. Now, you cannot just integrate this because this is a function of y. In order to do that, this is a step and it takes somewhat skill to do this. You can multiply both sides by y over x cubed. Both sides by y over x cubed. Alright. The rationale here is that here you can, if once you multiply that, it will only be a function of y because x cubed will cancel there. And then at the same time, this is also integrable as u to the n du. So you see that this becomes y over x cubed. Derivative of y over x is y cubed dy. And that's the time that what? You can integrate this already. That's integral. You will have what? You will have u to the n du is just what? Y over x to the fourth over 4 equals 1 over 4 y to the fourth plus c. Multiply by 4, you get y over 4 over x to the fourth minus y to the fourth is equal to, supposedly this is what? This is 4c, 4c, which is just equal to another constant. Let's call that c sub 1. So we have our what? We have our general solution. Let's have another example. Let's have this one. 4x cubed dy plus 3x squared y minus 3xy dx is 0. Let's expand. We have 4x cubed dy plus 3x squared y dx minus 3xy dx is 0. Then one particular step is we can combine this one, 4x cubed, and then the 3x squared y there, minus 3xy dx. The rationale behind this, perhaps we can factor the what? We can factor the x squared here, and you will have only a function of xy, and then x dy, and then you have a y dx there. So if you do that, factor x squared, you have 4x dy plus 3y dx minus 3xy dx is 0. We can take advantage of this rule that the derivative of x to the p y to the q is x to the p minus 1 y to the q minus 1 py dx plus qx dy. You see that what? Originally this is x squared 3y. Let's compare it here. 3y dx plus 4x dy minus 3xy dx is 0. So observe that what? Observe that the derivative of x to the p, we can consider p as 4, and then y to the what? Y to the cube, is equal to x p minus 1. That will be what? X to the, I'm sorry, it should have been I think it should have been x cubed, because this is 3, x cubed, and then y to the 4. This is this is x to the p minus 1, or 3 minus 1 is x squared, and then y cubed, and then p 3y dx plus what? Plus x plus qx dy. So plus qx dy, our q is what? 4x dy, x dy. So that is 4x dy. So you see what is missing is the y cube. you have only x squared, you have already x squared right away here. So you have to multiply, okay, both sides by what? By y cubed to make this exact. So this is y cubed x squared 3y dx plus 4xy dy minus, you have to multiply the missing term, which is y cubed 3xy dx is equal to y cubed times 0. And therefore, this now is the same as what? This now is the same as the derivative of what? The derivative of x cubed y to the fourth there, which is the same as that. So minus, this can be written as 3x y to the fourth dx is 0. Now you will have to divide, okay, you will have to divide this by a factor of x cubed y to the fourth raised to a certain value k, in such a way as this now will just be a function of x only, because you cannot integrate it if there is y. What particular value of k will eliminate y here? Obviously the value of k is just 1, because this is y to the fourth, y to the fourth. So this means that it's just 1 only. Derivative of x cubed y to the fourth, x cubed y to the fourth, minus 3x y to the fourth over x cubed y to the fourth dx is 0. Next step is, okay, divide. Okay, this of course will simplify. This term will of course simplify to only what? 3 over x squared. And then you can integrate this. This is just ln. So ln of x cubed y to the fourth. This is, what's the integral of 3 over x squared? Okay, remember that is the same as negative 3 x to the what? X to the negative 2. And the integral is negative 3x to the negative what? 1 over negative 1. Okay, that gives you simply 3 over x equals c. So this will be our what? This will be our general solution. Okay, next example, we have this one. Okay, y times x cubed minus y dx minus x times x cubed plus y dy is 0. Simplify, we have x cubed y dx, okay, minus, this is already combined on this one, this and this, minus x to the fourth dy, and then this and this, negative y squared dx minus xy dy is 0. The rationale is, we can, you see in the next step, we can factor x cubed there. Factoring x cubed gives you y dx minus x dy, and factoring negative y gives you y dx plus x dy. Alright, these what? These terms are what? These terms are elements of some common derivatives or differential. Okay, so remember that the derivative of x over y is what? Is y dx minus x dy over y squared, and the derivative of xy is x dy plus y dx. Now, the question is, what factor are you going to multiply in such a way as you can extract, okay, x over y here, and you can extract also xy here. But let us divide both sides first by y squared. So divide both sides first by y squared in order for you to have this element here. So you have x cubed y dx minus x dy over y squared minus y times y dx plus x dy over y squared equals 0. Simplifying, this is x cubed derivative of x over y minus derivative of xy over y, 0. Okay, you see this is, x is missing here. Here, okay, y is missing, but y should be the same as x cubed. So okay, y cube is missing. So here, okay, the thing is, we can just what? We can just divide this by what? Divide both sides by x squared y. Let's say to take you some time to think of why is it why do you have to divide by x squared y? Now look, if you divide this by x squared y, okay, here, then it will just be what? It The next step is it will be the derivative of xy. This will become xy over xy squared. And then here, if you divide this by x squared y, this will just be x over y, derivative of x over y. So here is a function of x over y, and here is a function of xy squared. It will take you some time to analyze that. Okay, it depends upon the condition in the problem. So now you can integrate that already. So integrating that already there, integral, okay, gives you, right, this is just what? This is just power, this is 1/2, or x over y squared over 2, and this is what? This is, okay, remember, this is the same as just negative, okay, xy to the negative 1, negative 2. And the derivative, or rather the integral, is just add 1. Okay, this is negative xy to the negative 2 plus 1 over negative 2 plus 1. And you have this what? And you have this final what? Final solution there. Okay, another example. Alright, this involves some trigonometric functions. Y1 plus y tan xy dx plus n tan xy dy is 0. Now you see that there is xy here, so expect a derivative of xy in order for you to determine an integrating factor here. Okay, multiply, you have dx plus y tan xy dx plus x tan xy dy is 0. Okay, factor tan xy dx plus tan xy y dx plus x dy is 0. Obviously, already there is a common integral, common derivative there. So you can replace that by the derivative of what? Tan xy, derivative of xy, and then finally integrating both sides. Okay, the integral is x plus len of secant xy, this is just tan u du, equals c, where notice that cosine xy is the same as 1 over secant xy. So you can rewrite this as x minus len of cosine xyc because of that what? Okay, because of that property there. So anyway, this is just the same as this one. They are both correct. Okay, that is the end of the discussion. Thank you and good day.